I am going to explain about ionization enthalpy or ionization energy. So what is the meaning of ionization energy? The energy is required to remove the loosely bound electron from isolated gaseous atom. Energy is required to remove the loosely bound electron from isolated gaseous atom. For example, consider it is an atom. Nucleus is positively charged and electrons are revolving around the nucleus, right? So this is an atom. So electron, the energy is required to remove this electron from the atom. It is ionization energy. Energy is required to, that means energy is always required here. That's why it is endothermic, not exothermic. Endothermic. Why? Because energy is required to remove the electron from it. Remove the electron from the atom. Remove the electron from it. So always energy is needed. Always energy is required here. That's why the system is endothermic. If the system energy is released, then it is exothermic. If the system energy is released, then exothermic. But here energy is needed, required here. That's why ionization energy or ionization enthalpy is always endothermic. Endothermic reactions. Endothermic system. Always energy is required here. So ionization energy means the energy is required to remove the electron from it. It is called as ionization energy. So remove the electron from isolated gaseous atom. So what is the meaning of isolated gaseous atom? What is the meaning of isolated gaseous atom? If any atom free from other atoms in gaseous state. I am saying if any atom free from the other atoms in a gaseous state, it is called as isolated gaseous atom. For example, consider it is a beaker and so many atoms are here. In gaseous state, every atom are free to move actually. Every atoms are free to move in gaseous state. That's why here one of the atom I am saying isolated gaseous atom. Why? Because I am saying isolated gaseous atom means any atom free from the other atoms in a gaseous state. It is called as isolated gaseous atom. So in this atom, energy is required to remove the electron from it. Energy is required to remove the electron from this atom is called as ionization energy. Ionization energy. So ionization energy and ionization enthalpy is always endothermic. Why? Because energy is always required, needed here. That's why endothermic. If any system releases the energy, then it is exothermic. And ionization energy is denoted by, ionization enthalpy is denoted by delta H. And the units for the ionization enthalpy is kilojoule per mole. This is the units of ionization energy. So first ionization energy and second ionization energy. First ionization energy and second ionization energy. So energy is required to remove the first electron. First ionization energy means energy is required to remove the first electron. Remove the first electron. And energy is required to remove the second electron. You have to observe clearly. So first ionization energy and first ionization and second ionization enthalpy matlab. So electron is energy is required to remove the first electron. Here energy is required to remove the second electron. So ionization enthalpy is depends upon two factors. Depends on two factors. One is attractions between nucleus and outer electrons. And the second one is repulsions between electrons. These two factors influences the ionization enthalpy. Why? Because I am saying attractions between the nucleus and outer electrons. It is very, very important. Attractions between the nucleus and outer electrons are very high, then we can't remove the electron from here. If the attractions is very high, we can't remove the electron from it. So higher energy is required. So, and the second factor is repulsions between the electrons. And repulsions, if multi-electron atoms, there is repulsions between the electrons. Repulsions between the electrons among them. So, these two factors influences the ionization enthalpy. If attractions are very high between nucleus and outer electrons, then we can't remove the electron from it. So, energy required highly here. And the repulsions between the electrons, multi-electron systems, multi-electron atoms have repulsions more. Generally multi-electrons placed in outer shell, then repulsions between them is very high. In that case also ionization enthalpy we needed high. So these two factors influences the ionization enthalpy. So ionization energy and ionization enthalpy, the difference between ionization energy and ionization enthalpy, what means? So ionization energy is just energy is required to remove, and ionization enthalpy is the change in energy. Simply the change in energy. Enthalpy means change in energy. Change in energy of 1 mole of the gaseous atom when outer electrons are removed. When outer electrons are removed, the change in energy of 1 mole of substances, it is called enthalpy, ionization enthalpy. Both are same, just little bit difference between them. So the noble gases have the highest, very highest ionization enthalpy, very highest among the all elements in the periodic table. Noble gases have the high ionization enthalpy. Why? Because noble gases what are? Helium, neon, argon, krypton, xenon, radon, right? So noble gases are helium, neon, argon, krypton, xenon, radon, right? So all these are noble gases. All these elements have the octet electronic configuration. Octet electronic configuration. That means 8 electrons present in the outermost shell. That's why noble gases all have the very stable. They are not participated in any chemical reaction. Why? Because noble gases are very stable. All these elements are very stable. Why? Because they all are having the octet configuration, octet electronic configuration. That's why noble gases are very stable. So noble gases have the highest ionization enthalpy. Why? Because noble gases have very stable electronic configuration. So we can't remove the electron from it. We can't remove the electron from it. It is very, very difficult. Why? Because very difficult. It is most stable. Why? Because octet electronic configuration. So we can't remove the electron from it. We can't remove the electron from it. So more energy is required. More energy is required. That's why more energy is required here to remove the electron from the noble gases. So that's why high ionization enthalpy. Noble gases have the high ionization enthalpy. Why? Because these are more stable. We can't remove the electron from it. If we remove the electron from it, we need more energy. That's why high ionization energy, high ionization enthalpy we needed. So among all elements in the periodic table, noble gases have the high ionization energy or enthalpy, and francium have very low ionization enthalpy. Francium, you have to remember, francium have low ionization enthalpy and noble gases have high ionization enthalpy. Ionization enthalpy changes in groups and periods. Groups and periods. Ionization enthalpy in groups from the top to bottom is decreases, and in periods from the left to right increases. In groups from the top to bottom decreases. Ionization enthalpy decreases from the top to bottom. Why? So here you have to observe that from the top to bottom the size of the element is increases. Size of the element is increases. Why? Because number of shells is increases here. 1s1, 2s1, 3s1, 4s1. That means the number of the shells is increases, the size is increases, and the attractions between the nucleus and outer electrons are decreases. Attractions are decreases here. Decreases here. That's why we can remove the electron from it very easily. That means less energy is needed. Less energy is needed here. We can remove the electron from it very easily. Why? Because attractions between the nucleus and outer electrons are very low. That's why the low from the top to bottom ionization enthalpy decreases. And here in periods you have to observe that from the left to right the size is remains same. Why? Because the number of shells is not increases. Number of shells is remains same. 2s1, 2s2, 2p1, 2p2, 2p3, 2p4. That means the number of shells is not increases. Just electrons are added to the same shell. Electrons are added to the same shell. That's why the size is remains same. If the size is remains same, attractions are very high. Attractions are very high between nucleus and outer electrons. If the attractions are very high, then obviously we can't remove the electron from it. We can't remove the electron from it. That means high energy is needed. High energy is required and needed. That's why ionization enthalpy is increases from left to right in periods. It is very simple. You have to understand. So in periods ionization enthalpy increases. Why? Because the size is not increases here. Size is remains same, 2s1, 2s2. That means number of shells is not increases. So attractions between the nucleus and outer electrons are very high. Attractions between the nucleus and outer electrons very high. So if the attractions is very high, then we can't remove the electron from it. We can't remove the electron from it So high energy is required. High energy is required here to remove the electron from it. That's why ionization enthalpy increases from left to right. and here decreases. Why? Because size is increases. So attractions is decreases between nucleus and outer electrons. If the attractions is decreases, then easily remove the electron from it. Easily remove the electron from it. So less energy is needed here. That's why ionization enthalpy is decreases here. Here increases from the top to bottom. In groups, left to right, in periods, ionization enthalpy increases. Thank you.